So we know what we're doing, don't we? We can build stuff based on what's already there. But what does it take to build and model from scratch? How do we do that? What do we need to learn? Is there something we're missing? Hi, my name's Ross, the creator and founder of Geordie Consulting and Geordie Intelligence, the YouTube channel you're watching right now. What we're talking about today is that data modeling piece, isn't it? How do we go from, well, I've got a load of data to, well, I've got some pretty pictures to show my management team. And even better, I've got something that we can gain some insights on and that can then help steer our business in a particular direction or move it forward or do anything like that that we want to do. What does that need to look like? All right, so let's start here with our little discussion into what goes on and what kind of things we're talking about when we say data and expanding into data, going beyond what we know. We've got this concept, haven't we, that we've got here, a nice visual. Yeah, we can see the pretty pictures, but where does that come from? Where that comes from is the data model. And this is really where we start. This is a nice simple, little bit more of a simplistic layout. This is kind of another one, but this is really where the model starts, okay? One of the things I always recommend to people is to use different models within their model or different layouts within their Power BI model to actually understand and explore and see what it means and what's happening at any particular point, because that's what you're going to need to do. You're going to need to be able to put together those structures, and it helps your mind if you focus in and say, right, I'm just looking at this little bit. How does this need to join together? Okay. But the main thing here is this, look at this. Okay. So from a business perspective, I'm not a data modeler. I'm not a data professional. I'm in the business because I'm great at finance, or I'm in the business because I'm great at HR. I'm in the business because I'm great at insert business function here. Suddenly you're asking me to understand data modeling. I don't understand what this means. You got a load of boxes with some lines. What's the point? I don't get it. And that's fine. There's not an issue with it. But it's important that you understand the concept that goes on. Okay, you don't need to know how to do it, but the concept is important. Right? And what I found was that we've got a nice way that we can actually talk about it. Okay, so let's go through, let's have a review of the thing, and then we can come back here and have a look and see, right, now I understand it, now makes sense. Yeah? Excellent. So here we are in Excel, okay? Do you remember when you were younger and there was a game, Cluedo, that you used to play, and you used to have, it was a board game, you'd roll the dice and you'd move your player, which was one of the people who could be the murderer, around a mythical mansion that was the playing board, and you go to rooms and you try and find out with your cards which weapons had been used or which weapons were available. So you then had the one through a process of elimination, you would kind of get to the point of going, the murder was committed by, dun, 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 okay? All the drama, all the excitement, okay? Amazing. This is a perfect example, okay, of what data modeling is, right? So we've kind of got here, haven't we? We've got 6 people, got 6 weapons, and we've got 9 rooms, right? So we know one of these people, we need to take one thing from a person or from a people list, one thing from the weapon list, and one thing from the room list to have the instance of a murder. And that instance is really what's important to us, okay? We need to understand what that means in the parlance of data, don't we? So let's start simply. People, we can see, well, people are people, aren't they? There's a physical person there. Weapons, there's a physical thing, a physical weapon there. And rooms, there's a physical place, there's something physical to it. Okay, and these are examples of dimensions. They are something that may be intangible, but there's something very finite and defined about them. These are a definite article of some description. Okay, You know, the exception ones that tend to be are things like time, like a date. How is today like an entity? It's not, but it is, in that it has a clearly defined space. These are dimensions, right? So we have people, we have weapons, we have rooms. Okay? And then, yeah, okay, we could say, well, we could have dates as well, couldn't we? We could put dates in as well for it. But what we know is that at some point, we need to be able to say people, weapon, room. So in this game, the murder was committed by Colonel Mustard with the dagger in the study. Okay? And I can write that. That's great. And we can then write a lookup script that will look those up. And then next time we have a game, we could say, all right, that was the murderer was Mrs. White with the rope in the kitchen. And we can keep doing that. But that seems a bit hard, isn't it? I've got to manually write all those things down. So it's long-winded, isn't it? We don't want to keep doing that. But what we've done here is we've drawn these entities together. And when dimensions come together in a structure, okay, when there's commonality between them, this row becomes a fact. Yeah? So the fact is the murder was committed by Colonel Mustard with the dagger in the study. The murder was committed by Mrs. White with the rope in the kitchen. Facts, right? So we suddenly have a fact table forming, right? But in order to avoid having to keep writing it, what we would do is we'd say, well, let's use a formula for it. So, okay, so let's build that join so that we know people is only going to come from the people table. Weapons are only going to come from the weapons table. And rooms are only going to come from the rooms table. So we'd build a lookup if we were doing it normally. Okay, for the sake of this, I'm going to do something a bit different. Okay, and it'll make sense when you see it. But we want to build a fact table. We want to be able to say, right, we're going to track 50, 100, 1,000, a million games of Cluedo, and then analyze the results and come up with what's going on with it. Okay. So instead of saying Colonel Mustard here, let's zoom in. So what I'm going to say is I'm going to say equals index, open brackets. We want this table where rand between one or rows. Oh, it's moved. Open brackets. That's table one. My goodness. No autocomplete is there in Excel. Oh, my goodness me. People or tab for autocomplete. There we go. Okay. What have I missed? 1, 2. Is it assumed I've put something else somewhere? Accept the correction. Okay. So you can see it's now changed, say, Miss Scarlet. Right? We've written a random function in there that's just going to pull that value in. We're going to do the same here. Okay. So equals. You use a drop-down list picker kind of thing for these, and then you just go through. But for this, it just makes it easier to do this. Okay. Index, open brackets, weapons table. As I say, don't worry about these formulas. They're just rand between 1, rows, open brackets. Why does it not like that? What's it saying? Found a typo. Is it 3 close brackets? Must be 3. It is 3, rand between, yeah, sorry. Okay, that's my fault. Equals, I'll do it right this time. Index, open brackets, rooms, comma, rand between, open brackets, 1, comma, rows, open brackets. There we go. Put 4 in this time because I'm that good. All right. So we can zoom out, right? And suddenly we've got the beginnings of a table, haven't we? So if we hit Control T to make that a table, of course it has headers. We can now expand that down as far as we want. Okay. So we've suddenly got lots and lots of rows of data. Okay. So this is now suddenly our record of what's happened. And it now makes sense, doesn't it, as this is a fact table. So we can see we have joins from people, joins from weapons, and joins from room. And if we went back to here, we could say, let's insert some arrows, okay, because that helps make sense in our minds as to what we've done. So we can say, well, we've taken this from here to here. Okay, let's make that orange. Let's make that bigger. Okay, let's hit Control-C, Control-V, because we've taken that going to there, and then one more because we've taken that to there. Okay, so we've done this, right? And it's far too much like hard work. Okay, this is ridiculous. Okay, this is hard work. Why on earth would we do it? Okay, and the reality would be, if we went to do this properly, right? And let's just copy this over to here. Okay, we would then say, well, we've got this. So we want to have gender. We may want to have big one in America, education level. And I can't spell it. You could have salary. You could have, okay? You could go on, right? And you would build out more and more and more for that. And those other features, these other values, would help give you commonality to work out a piece from it. There's another board game, wasn't there, where you had to, was it pick Spudhead or something? I can't remember. Guess Who? That was it, okay? And you'd use that to pick out commonality. So you're expanding that dimension beyond just the simple lookup value that you have. And of course, so we'd need to put in the index, wouldn't we, to make that work? So we'd put in what, 1, 2, 3, 4, 4, 5, 6. Okay, that's all we would do, right? You could write formulas for that. It's not going to make a big difference. That's going to help you in terms of the complexity of the formula for you, because it's a row headers yet to do it. But what we can do then is we can say, well, let's say this is going to be F, M, F, M, FF, for example, education. So we can say like college, high school, college, high school, college, say for okay. You can go on, you could imagine, okay, we could go through. So we're building suddenly up this whole dimension. We could then turn around and say, well, looking at this, if we cross-reference that back to there, what's it going to be? But what we would probably do as well to make it more efficient is we would reference and use the index for the fact table, okay? So the other thing we can do as well with this is to understand that if we were doing this traditionally, so before we used this and we were just doing this in Excel, what we would probably do is we would take the information from here. Okay, so I'm just going to take one row from here, okay, just because I think that makes it a little bit easier to understand. Okay, so for a murder, for example, if we're going to pretend we're entering in a fact table for this, okay, we'd say weapon, we might have the weapon type, we might have, so what we had, revolver, didn't we? That's what we were talking about, wasn't it? Which is type firearm, a weapon index, okay, because we'll probably have that, so we'll say that's 10-3, and then we'd have the room, wouldn't we? So we have room, it was study, wasn't it? Study, we'll have the size of the room, so size, room size, so let's say that's 20 square meters. A room index, say 6, okay? So suddenly we've got a really wide data table. And if you imagine that went on further and further and further, we had more and more rows of that, the amount of storage that you're going to need it goes up exponentially, okay? It significantly gets bigger and bigger and bigger and bigger, but the value that you're getting from it isn't increased. So what you actually have is this model here. The ability to use facts and dimensions and those joins make it much easier, especially then when we turn and say, well, we want to just look and see, well, how many times has the murder been committed by somebody who's had a college level education as opposed to a high school level education, by a man, by a woman, by whatever else we choose to put in there. Okay, and there's lots that you can do with these. And the point about data modeling is that dimensions will change over time. Okay, you will want to add additional information to dimensions. Facts can't really change because they can't. You can add dimensions to a fact, but the fact itself is still the case that, in this case, Professor Plum did kill somebody with the candlestick in the library. That's not going to change. We might add a date dimension so we could track these, well, when was the game of Cluedo played? But that fact would still remain. All we would have done is added something to it. Okay? And then within that date dimension, we can say, well, what about the month was that? What year was that? What quarter? What anything like that? What phase of the moon was it? In terms of, is there a lunar effect on who the murderer is in a game of Cluedo? I don't know. Okay, but that does beg rather an interesting question, doesn't it? Okay, if, for example, we went through and we did that, and we suddenly found out that full moons tended to mean that Professor Green committed the murder. The Reverend Green committed the murder with the resolve. I thought Chris Fulmer said somebody else. In the study with the fight with the revolver. That tended to happen much more on full moons. So we've got a correlation. Is it causal? Okay. Do full moons really cause our game of cards to be affected? I hope you can say, no, of course they don't, right? Correlations and causations are one of the biggest misnomers that you get in statistics and in analysis, right? And it's one of those things that we need to go through and work out, is something actually statistically verifiable, to work out, say, well, yeah, okay, this is something we can then say there is a causation to it, as opposed to it's just random, right? And there's a whole piece and a whole science around it. And the fact we said science should indicate to you what we mean. That's the realm of data science. Okay, data science's role is to look at your data and say, hey, it's a bit clumpy in this way. There's something here. We can detect a correlation. Is it causal? Is it something that we should be saying, this is something that we should be monitoring and that will have a direct impact on our business? Ideally, you want those causes to be something you can do something about. Like, customers are more satisfied if they're looked after well, for example. So when our customer service agents aren't trained, very surly, for some reason we tend to see our customer service metrics go down. Who'd have thunk? Okay, so we could then say, right, we're going to use that as a way to say we need to train these staff more. Okay, no problem. If we went around and said, oh, okay, we've found full moon affects this, well, there's not really much I can do. It might well be that, yes, there's a correlation there, and yes, it is more that it's some cause to it. We can say this actually is a genuine correlation and causal correlation. And it might be as simple as saying, well, in retail, there's issues with all sorts of things where people potentially they're worried about something coming up. So they will prepare for it. If people are worried about the full moon, they will prepare for it. They'd go and buy more. So you would see a change of spending patterns. It's causal, but it's not something you could influence. When something is causal and you can't influence it, it should stay in the realms of data science. If something's a correlation and it's just random, like completely random. So if we say things like the other one which is famous is hemlines and recession, there is no way you'd want that reported up on a board. Hemlines are at this point. We're going to, but it would be something that you would definitely be keeping an eye on at the data science level, a smaller group of people having a look at it. Okay? Business intelligence. Okay, and the core functions of data analytics, business intelligence is that. It's very much about having that industrialized platform of numbers that are going to underpin the decisions that go on in your business. Right? Data science has no place in business intelligence. Business intelligence has no place in data science. But the two complement each other in that business intelligence gives a very firm foundation for data science to jump off from, in terms of, we've identified this in the data, in the business intelligence data, to then say, we want to investigate this further and see, is there something we can do to drive improvements into the business? And that drive improvements in is where they need to be structured and built effectively so they can flow in. It's important, okay? Likewise, from a business intelligence, from a business intelligence perspective, we will expect to receive feedback from data science as they identify new things as well. So, oh, hey, we found out that we need this. There's a better way of tracking our customer service metrics that's more efficient, has less lag time, this, that, other. That would go through an approval process, update the metrics packs that would then flow through into your line of business reporting. So you've got kind of rigid, structured business intelligence and that more ad hoc, exploratory data science. Two are complementary, two are equally important, but they are worlds apart. Okay? Kind of understand that. So we've got to this. Let's go to a different one, kind of one I did earlier. Okay, just to kind of, let's revisit this. Okay, so we've got here, right, where we've pulled this information together. We've got the indexes, and we can see, right, I've put in the numbers this time. So what we would have to do here, if we looked at this row, just for example, just because it's easier, and I wish I could see, there was a feature that appeared in this for like 20 minutes, it seemed like, which was brilliant, and I can't find it, and it's annoying me so much. It was where suddenly you could highlight the cell and it would show everything in that row. And I'm sure I've done it on a video, and since then it's disappeared again, and I'm so annoyed because it was such a useful feature. But anyway, okay. It says, isn't it, focus cell? Duh. Okay, so if we bring on focus cell, what we can suddenly see is, let's pick one down here. Let's pick 3 here. Okay, this row here. So we've got person number 1, Professor Green. Oh, sorry, Reverend Green. With 2, with the candlestick. Oh, wow, this is brilliant. With 7 in the library. I did not plan that. Okay, so we've suddenly got this ability that we can do it. So we can see we could cross-reference that back and forth. So if we went here and we looked, yeah, we've got these joins going this way, and we're suddenly realizing, the joins, for all we've put them that way, the reality is the way they work is not that way. They work the other way in essence, because we go and we look from the fact to the dimension. From the fact, we look up the dimensions. Okay, which is why we talk about one dimension is used many times, okay, in terms of the way it's set up. So there's a one-to-many relationship following this arrow. But the reality is that we say that because the way we would want to express it is normally we would say we want to aggregate fact data. So we aggregate that back into the dimensions. So we would look up and see, if we went here, we could say equals, what's this? Let's just do this. It's just easier. Oh, we don't need to do that. Let's just do it this way. Count if that equals that. Yeah. Okay, and suddenly we'd get that. So we can suddenly start to see. So we'd be looking back, you'd all say, oh, okay, I get that. But you see, I'm adding all the time with this into Excel. We're having to add stuff, aren't we? Okay, which we don't want to do. This would be part of a measure, wouldn't it? We wouldn't want this to be in our data set here. So we would, we'd need to remove this. Okay, so we can, but anyway. Okay, so we'd start to get to this point, don't we, where we remove, or we're not putting stuff in all the time. We're letting stuff be used within the tooling, but we aren't bringing it into the tooling all the time. Does that make sense? I hope it does. I know it's a bit of a weird one the way I've put it. Okay, in terms of it, the realities, if we go back to here, right, let's pick a new one of this, and let's say, right, I'm going to look at people. Okay, people. Okay, so people take part in an event. Okay, they participate. Okay, an event is a difficult thing. Okay, because an event is multiple things to pull together. Events, it's a complex example, so we won't talk about events, but they take part in an event. Okay, so we have participation. So we can see there's a one-to-many relationship between people and participation, because one person, me, I could do many events. I could do many parkruns. Okay, yeah, no problem. I can understand that. Okay, and those events will take place on a certain point. So we can then build up, there's more and more information to that. This is fundamentally the simple structure that goes on with it. Okay, the reality is these things are never that simple. Okay, and as we say, they're never that simple. So if we look here at it a bit more expanded out, what we actually find is we can follow it. So one to many, yeah, one person can do many events, but then have calendar. So one day can have many events because all our parkruns can take place on the same day. Okay, so each day we've got lots of events taking place. And then we have this issue, and this is why we have the participation table, is that we end up with what would be a many-to-many relationship, because for all one person can only do one event each day, there's going to be many-to-many, because over time there's going to be lots of it. So each event is going to have many people, and one person is going to be able to do many events over time. So we end up building what's called a link table, and a link table is used very often in analysis. So classic examples would be things like if you're doing a school timetable, for example, where you have, if you think in a school timetable, you've got day of week, you've got time or period, you've got staff member, you've got potentially you've got subject, and then you've also got pupils. Bring all that information together, you end up with a structure very similar to this, where you have a link table to link together, effectively bringing it all together. So which room, which teacher, which pupils are going into that. And that's how it works, these link tables. So you have a link table. So that's our link table there. But this structure goes through. And it's easier to understand it like that, isn't it? Than trying to look and say, oh yeah, I can make sense of that. So never worry when you see something like this in Power BI. Remember, this is me connected to the semantic model. I am not developing it. I'm not a developer against this, but I have the ability, just with my basic knowledge and basic license, to come through and say, right, I'm interested in people. For people, I can right click and I can say, let's add the related tables. I go, oh, okay, I can see how that works in terms of how that's joined together. I could say, oh, I'm interested in participation, okay, which was here. And we could say, right, so let's now add the related tables to participation. And we get more information. So I could choose what it is I want to do, bring that through, and I've got this then as a layout. And all I would say is just rename it. So people and participation, okay? And you can start to piece together everything that's taking place across your Power BI models, and then you can start to do more. But remember, when you come to build your new stuff, you now have as well that deeper understanding about what goes on with this. Yeah? So should we do some building next week? I think we should. So data modeling is always expanding, okay? This is never something that you're going to say, I've learned data modeling, I don't have to do it. I learn something new every time I do a data model, I'll be honest. Okay? There's always little things you go, oh, I've not done it this way before, or oh, we've got a challenge, we need to work out the best way to cope with this. That's what will happen, okay? The reason why data modeling is so important is it's all about understanding the aggregation flow, okay? Analysis is about aggregation. If somebody tells you differently, they're wrong, okay? They're just straight up wrong. You want to know, how many sales did we get last week? That's aggregate the sales table, isn't it? Give me the total sales number, total sales amount. You know, how many of our new products did we sell? That's aggregate the sales numbers for that. Okay, there's no, this isn't aggregation. That's what we do consistently. And the most efficient way to do that is to present a column. Okay, this is what tabular modeling does, is it presents a column. And then we sum up that column, we average that column, we take a min, a max, a standard deviation from that column. Okay, then from that column, we want to cut bits out. Okay, we just want to use this little bit of the column. And that's what using the fact table structure does for us. Okay, because we can say where killer equals Colonel Mustard, where weapon equals rope, where room equals something. And we can filter that fact, and then we get how many times did that occur. Simple. But that's still just using that single column that we're able to produce because we've got that fact table. And then that fact table becomes narrow, but it becomes very long. But we don't mind it being long because we're always just going to say, well, just this bit, just that bit, just this bit, that bit. And we can easily then filter down what we need to then say, well, how many rows have we got in there? What's the total row count? Because that would be all we'd want, count the rows in the table. And then tell me how many of whatever we wanted to look at. What's left of that table when we filter it by whatever, okay? And suddenly, you've actually seen what's going on within Power BI behind the scenes, okay? That is literally the way analysis should work in a perfect world. That is the way we aim to get our data models to. That is the structures that we want to put in place so that we can quickly get to and filter quickly to then say, look, right, this total column, which is everything, we just want this section of it. Give me the total, give me the sum, give me the average, give me the min, give me the max, give me the standard deviation from it. But it's all just find that column, work through that column, okay? And then use your facts and dimensions to help filter that column down to get that subset that you need for analysis. Okay? I hope that helped, all right? Data modeling is one of those topics that it goes on, it goes on, it goes on. I've seen demos, I've done sessions, I've run hundreds of sessions of these going through and saying, right, this is how we're going to start data modeling. No matter what I do, there'll be some of you who get it, there'll be some who don't. What I would say is think about what's happened, right? Understand this bit. If you've got questions, ask them down below, right? If there's something that you're doing and saying, well, I don't quite, it doesn't make sense, break it down, okay? We've got some videos where we've actually done a more structured in Excel, let's take a data set and piece it together. I was going to do that for this, but I thought, no, I wanted to go in and actually have a look at this. And the Cluedo idea just kind of came to me. Oh, Cluedo's actually really good because it really spells out what goes on. So I hope we've kind of worked through the concepts for you. And then there's an example video, as I say, I'll put it up there. Have a look, have a watch, okay? I hope that made sense to you. I hope you enjoyed it. I hope it hasn't made you think, oh, I understand. Okay, but I hope it's also led you to think, I now understand what goes on. I understand now why things are that way in our analysis environment. For now though, stay safe, take care, ta-da.